Hello, everyone.
Hi, how are you?
Good, how are you? Today we'll be working on starting a new topic. We are supposed to start this topic last Friday, but we didn't have a class, so we're beginning the topic today. And this topic will be the I think I opened so many pages here. Anyway, the topic will be um, normal, actually, continuous probability distributions. So under the continuous probability distribution, let me put this way. Continuous probability distributions. So under this group, we have the normal distribution. Okay. Let me make this bigger so we can see it where it should be. Now, I say under this we have the normal distribution. I will also have the uniform distribution. Then we have the exponential. Distribution. So, but we are only interested in for this class, we'll be dealing with only the normal distribution. And that is what we are starting today. Normal distribution. So before we start, I want to refer you to that table I mentioned last week. The table I have it uploaded for you in the your class. So let me show you where it is located. You have to really download this table because that's what we'll be using it from now on. Yeah. Let me open the table, show you. It is located in the files section. So this is the file section. You can then have access to the table. Okay, it's here. Just 1 minute. Now, so this right here. This is your class right here. And if you go to the files section of your class, you will see the handout you're working on today, class handout 6. Now, this is the table I'm talking about here. Statistical tables. Not this. This one is the same thing. Type of table that I want to use this one. You can download it here. I have it downloaded here for you. I mean myself, because like I said, we'll be using it for this class. See, this is how it looks like. We use it for the binomial distribution. Now for normal, which we'll be covering this week and part of next week, we'll be using this part of the table, table 5, which should be the standard normal areas under the standard normal distribution. Now, there are 3 different versions of this table. There's one that is a cumulative, and the one that is in form of a percentage. Then there's this one. I recommend that we use the one we're using in the class so that you don't get confused. However, if you know how to use the other versions of the table, other types, you still get the same results. If you know how to use them, then use them. But I usually recommend using the one we're using in the class to avoid confusing yourself with the requirements of different tables, because each of them have a way to use them. So that table, like I said, it is here. So I encourage you to download it from your course website, log into your class, go to files. This is the Statistical Table 2017. Download it and then use it. Okay. So we'll be using it now till the end of the class. Now, having said that, I can log out now so that we can begin the class. Matter of fact, I'm going to close this part so that we don't have so many things opened up. Okay. So let me share my screen again. All right. Okay. So like I said, today we are working on normal distribution. The basic concept, many continuous variables. Remember, continuous variables are those variables that can be measured. They can be measured, not counted. Discrete variables can be counted, but continuous cannot be counted. Variables like the height of men or height of women, temperature, cholesterol level of adults, and so on. So many continuous variables have distributions that are bell-shaped. So those distributions are known as normal distribution, or bell-shaped distribution, or Gaussian distribution. Now, we say that they are bell-shaped because they are shaped like a bell. If you remember the church bell in those days, when the church bells rang on Sundays, Sunday mornings. Well, anyway, that's, if you plot them, like, let me put it this way. If you plot the height of the students in this class, it will give you like a histogram that is not equal. Some will be taller. You know, it won't give you this kind of shape. But if you plot the height of all the students that take statistics classes in Maryland, it will give you this smooth curve. Some will be very tall, some will be, but at least they will be at that height that we expect an adult person to be. Yeah. So that will give you this curve. So the same thing with temperature and so on. So this leads us to this simple definition of the normal distribution. Okay. Now, the simple definition now says the normal distribution is a continuous, symmetric, bell-shaped distribution of a variable. So we use it to describe many variables because of the deviation from those normal are very small. Now, let me give examples of this. The normal range of systolic blood pressure, normal range. The normal range is 110 to 140 millimeter mercury. So if above that, it's not normal. Below that, it's not normal. You know, that one is low blood pressure. Then above that will be high blood pressure, but this is the normal range. You can fall in within this range. It can be 110, 111 to 139, okay? 120 to 137, they're still good, so long as you fall within this normal range. Now, excuse me. Now the next is the okay, the normal interval for a person triglycerides is from 30 to 200 milligram per deciliter. So anything above that is not normal. When it's above that, it becomes high cholesterol. If it's below 30, you know, that's low cholesterol. Now, but the normal range is that. So any above and below is not good and can affect you. Now, how about this? The average birth weight for human babies, 6 pounds to 9 pounds. If it's below 6 pounds, that means underweight baby. Something that might be wrong. And if above that, is that the baby is overweight. You know. So I mean, I can give you so many examples. That's it that I say to be normal. You know. Now, which will bring us to the properties of normal distribution. So the properties of the normal distribution are as follows. A normal distribution curve is bell-shaped. See, this is the normal distribution curve. It is bell-shaped. See, it is bell-shaped. It is shaped like a bell. that is placed down. See, I want half of one side is the same and the other side. So now, second one is that the mean, median, and mode are equal and are located at the center of the distribution. See, but normally, see, both the mean, median, and mode are equal and they are located at this center. Okay. And the third property is that a normal distribution is unimodal. It has only one mode. Mode is the number with the highest frequency. See, top here is the mode. It doesn't have two modes. Then the curve is symmetric about the mean. Okay, this is the mean right here. Half of this and the other half, they are equal. What you see here, this is like a mirror image. The left side is like a mirror image of the right side. You know. Yeah. Then the curve is continuous. That is, there's no gaps. It keeps going. It never touches this line. See, it keeps getting closer, but never touches it. It's asymptotic, like it's the saying mass. The curve never touches the x-axis, and the total area under the curve is 1 or 100%. This side is 0.15. Half of this is 0.5. The other half is 0.5, which gives it a total area of 0.5 plus 0.5, which is 1.0, or I call it 100%. See? So there are other properties that I may not I didn't mention here, but these are the basic one that you need to know at this level. Any question before I continue? Any question, class? Okay, I think okay. Give me 1 minute. Yeah. Any questions?
No.
Good.
Not for me.
Now let's see. For this class, we'll be looking at our interest would be on the how to find. We start with how to find the area under the standard normal curve. Okay, the area under the standard normal. So the first step is to draw the curve. The second step will be to use the table that I just did. That table I showed you, that is located in the file section, to find the area, and then do the math there. Remember that you have 0.5 on this side and 0.5 on that side. So let's see how to calculate this area under the standard normal curve. So it says find the area. Make it bigger. Maybe we can try two of them on this side. Okay. Okay. Now we are about to start. You say find the area. Calculating the areas under the standard normal curve. So find the area under the standard normal curve, which lies to the left of 0.94. Okay, that's A. Say to the left of 0.94. The first thing you do is to draw the curve. Okay. So you're talking about Z equals 0.94. The left of it. Okay. So now what you're going to do is to draw the curve. So I'm going to draw the curve on this side. Make sure you're seeing this. Okay, good. So we start by inserting the curve. I'm gonna use let's see. We got to choose the appropriate this to draw it. Let me see if this one will work. Okay, I think this will work. Oh, I think I missed it. Okay, let me try another one. Okay, I'm gonna delete this. So let's do it again. Yeah. This should be working. So I'm gonna make it here. Okay. Now I'm gonna put the center. Okay. Now, if you're using pencil and paper, this has become easier. Or if you're writing on the board, but we're doing it on the computer, like this. Except if you're a good, if you have somebody who knows how to draw with a computer, it becomes, a challenge a little bit. But I'm gonna try my best to give you what you need on this. Then the center, okay, which is the 0. Okay. Now you can put the 0.94. This center is always 0. Okay, 0 was the mean for the standard normal distribution. So we're going to come to that. Let me read this a little bit. Okay, so I can move this up a little bit. Okay. Now with that, we have our 0.94. So left side is negative, right side is positive. Now, negative means it's on the left side, not that it is negative value. So I'm gonna put 0.95 anywhere on the right side because it's positive. Okay. 0.95. 0.95. So but we are looking for the area to the left of it, left of 0.95. So that means we're gonna shed. We're looking for everything on the left side from here to the left side. So we're gonna shed them. We're gonna shed it. So I'll start from here to shed it. If you know how to color things, you can, it's become easier. So this is the area we're looking for. Okay. If I put the color, it will color the whole thing. So let me just use a curve. Area we're looking for is here. All the shaded places are to the left of 0.95. So we're gonna shade them. Okay. Now, okay, one more. Oh, excuse me. One more we put here, and then we'll be good. So now, all this shaded portion represent the area to the left of 0.95. So the required area becomes area equals. Now, if you remember, when I was introducing this curve, I told you that half of this is 0.5, another half is 0.5. Now, the half of this is already 0.5. So we got to write 0.5 here. Now, plus the other part half of it. Remember, this side, we didn't take everything. We take only this portion that represents 0.95. So this place is one we look for in the table because we don't know what it is. So that will take us to the table of normal distribution. So we have I'll take you there so you can see here, that's the table right here. You can see the Z right here. I see the table area of a standard normal distribution. So 0.9 is gonna be here. See the 0.9 right here, under 5. So that will give us 0.95. So 0.9, you go under 5. Under 5. 0.3289. Right there. 0.328. So 0.95. I think it's 0.95 or is it 0.94? Let me make sure it's 0.95 or 0.94 we're looking for. Oh, 0.94, right? It's 0.94 because say area 0.94. Okay. So I'm gonna take you back there. So you got 0.9, you go under, this is 4 right here. So 0.9 under 4 right here. That's the area we're looking for. 0.32 64. See 0.3264. Let me write it down so I can forget this. 0.3264. So, and that will give us the answer we are looking for. 0.3264. So to get the answer now, we can now look at our decimals calculator and see 0.3264, 0.5 plus 0.3264. You have 0.8264. Right. 0.8264. So 0.8264. 0.8264, or if you like, I can call it 82.64%. Any question for this?
No.
So that is basically what it is. Now, why do we have to draw a curve? Because the curve will tell us exactly what we do. If you look at this curve, it told us that we have to add 0.5, this part that is completely, and then look for this and add it. So I will do one more example on that, then we'll go to the next stage. Let's say that we have this type of question. Let's say we have where you give us two sides, like between, when you say between, sorry, excuse me. Yep, this can be it. Between Z 0.87 and Z 1.28. Okay, we have solution in this form. So I'm gonna write between Z equals to 0.87 and Z equals 1.28. 1.28. Okay. Again, I mean, notice that I skip this one because I know they're basically the same thing. Like this one is gonna be to the right on the negative side, you know. And because we are going to do more examples here, when we look at it as a probability value. Okay. So now, between these two values, again, we draw our charts first of all. Chart will be, okay, I'll start from here. Okay. Then, and then we have, away. Then we have the x-axis of the charts, and then we have this here. Okay. Now, you see between these two values, remember the center is 0. Center is 0. Is 0. So between these two, 0.87 positive. So I'm gonna put 0.87 here, and then this is 0.87. Any side of the right side closest to 0. Let me bring this down so that you can be closer. Yeah, a little bit. Okay. And a little bit. Okay. Now this is it can be. plotting closer a little bit. So this would be 0.87, and the other one is 1.28. So I'm gonna put it 1.28. Have it on this side. Let's say this is 1.28. 1.28. See, between them, that means from here to here only. In that case, we can share the portion that represents between the two values. So we're going to share from here. Okay. And then share here. Okay. So that you should not notice that this one didn't start from 0. It started from 0.87 to 1.28, not from 0 to 1.28. I want you to take note of that, because that's basically what it is, you know. And one more and we are good. Okay, so that's the value, but actually 2 more and we're good. So now let's the area we're looking for here between this and that. So in that case, let's find the area. Area will now become, now when it is between these two values of this type, what you do is to find the area for both of these two, and then subtract this smaller area from larger areas. So this is the bigger z value. So let's find it first. 1.2 under 8. So I'll take you to the table. 1.2 under 8. See 1.2 right here. See z 1.2. They have to go under 8. I'm gonna write this down. Okay. So 1.2, 1.2 right there. Then you go under 8. You can see under 8, okay? 8 right here, under 8. 0.3997. 0.3997 minus. Now, next one is to find 0.87. 0.87. Now, if you're using a different type of table, like the cumulative one, you'll be following a different step, not this step. See, that's why I said stick with this table so that they won't get confused. Now, if you're using a cumulative table and you are following the different step as specified in that step for that table, you get the same answer. It's just the different steps. Okay. So 0.87, maybe look at 0.8 under 7. 0.8 is right here. Then you go under 7. You can see right here, see the 7 right there. So 0.8 under 7, maybe 0.3078. And that will give you the area you're looking for the work. So you're looking for only this portion, not from halfway. So area will now becomes for this one here, we got for 1.28, we got 0.3997 on the table. And for 0.87, we got 0.3078 from the table. And when we subtract them, now we can get the area we're looking for. Okay. Let's subtract them. So we have 0.3997 minus 0.3078. That gives 0.0919. 0.0919. So we can now put the answer for the area. 0.0919 0919, which can be written as 9.19%. Questions?
No.
No.
Okay, very good. So now another way is to do this. Another way they ask question about this is they can ask it to as if it is a probability question. Like instead of asking you to find the area between 0.34, 0.87 to 1.28, they can ask you. They can ask the question this way. They can say, find the probability of 0.87. They can put it in this form, say less than z, less than 1.28. So it is the same thing I'm asking you to find the area between this and that. They can ask it in this form. Okay. So this is just a different way of asking the same question. That's what we have here. Where it says, find the probability of just 1 minute. Find the probability for each of these values. Say P0 less than Z less than 2.32. It's just a way of saying find the area between 0 and 2.34. And for this one, you say P 1.12 less than Z less than 1.43. It's the same way I say find the area between Z 1.12 to 1. So it's the same thing basically. So now I'm going to do 2 more examples. We have been doing the one that is normal. Sometimes it might be on the tail. Let's try one that is on the tail. Okay, and then we can try one where one of the answers, one of the Z is negative and the other one is positive. Yeah. So for example, let's do this one that is on the tail side. You say find the area, find the PZ equals 1.65. That's the one we are looking for. Okay, let me copy this. Okay. It's a probability of solution of Z 1.65. Now, again, like I say, what you do is to draw the chart, draw the correct chart. Chart basically tells you what to do. So we come here and put the charts. Okay. Then put the x-axis of the chart. And my chart may not look good, so but at least better than nothing. Now you can put the center. Okay, which is our 0. 0. Now it says greater than 1.65. Let's say this is 1.65 here. So I'm gonna put the line to represent 1.65, 1.65. So we put the line that will represent it. 1.65 is here. Then it says, but we're not looking for 1.6 probability of 1.65. We're looking for the probability that Z is greater than 1.65. That means everything to the right of it. So that means we're gonna shed it. It'll look like this. Okay. All right. Okay. Like this. Goes this way. All right. I think 3 more. We done with the schedule. Okay, 1 more. I mean 3 more. I need to say. All right. masked shading. Okay, so this kind, we say that it is at the tail. Tail. Now, this is the right tail because it is positive side of it. This is what we call the tail. See? So the tail. Now it can be on the left tail. If it is less than negative 1.65, then this tail will be on the left side. Either way, because it is symmetric, it is still the same thing. It doesn't matter. Okay. Now, so that means we're looking for only this area, and you recall when I introduced this, I mentioned that the area in the normal curve, half of this is 0.5, the other half is 0.5, so that the total is 1, which is 100%. So we are looking for only one portion of that. See, half of this is 0.5, the other half is 0.5. So we are looking for only this part. That means you're going to subtract it from 0.5. Subtract what you see on the table from 0.5. That means 0.5 minus. Now we're going to look for 1.65 on the table. So that will give us only this part. Okay, 1.65. So I will now take you back to the table. Excuse me. I think 1.65 is 1.6 right here. Then you go on that 5. So you can see that it is 1.6 and it is under 5. 0.4505. 0.4505. Okay. 0.4505. Now we're going to write it down. Okay. Minus 0.4505. So which we can now use the decimals. I think it's 1.65, I believe. Anyway, 0.4505 for 1.65. Now, decimals we can use 0.5 minus 0.4505. 0.49, 0.049, 0.0495. So that our answer becomes 0.0495. Or if you like, you can write as 4.95%. So by now you can now see that the shape of the curve will tell you, will dictate what what you do, whether you to add or subtract. Now, the last example I want to do round up is where we have this type of equation where it says solution. Okay, and it says between these two values, P probability of negative 2.46 less than Z less than 1.74. And that's what we are looking for. Now, you see, one of them is negative, one of them is positive. So we have to, negative is just to show you that it is on the left side. That's all. Now, some tables have a different section, like the cumulative table for the negative Z. This one doesn't have it, but it showed that this negative is left side. So when you go to the table, you don't look for negative 2.46, just look for 2.46 because, like I say, it is symmetric. So it is either the same both ways. But the one will be on the left side, the other will be on the right side, the positive will be on the right side. Again, for this, we make our chart in this form. Okay, we have the insert chart. Okay, then okay. All right. Okay. Now we can now put the x-axis for this chart. Okay. And then we can now put the mean of 0, which is 0 center of 0. Now it says, the first one saying to the left is negative 2.46, which is the left side. Okay. Okay, let me go this way. Up negative 2.46. Okay. And then to the right, you have 1.74. Right is 1.74. So we can now put the line that will link represent those z values. So this is for this one here, 1.74, and this is for the z value of okay, 1. This is negative 2.46. Okay, now say between them, that means between here and here. So that's what we're gonna share them. We share this. Okay, and that will give us the area we're looking for, the probability we're looking for. Okay. Like I said, with a freehand drawing, it's easier. But with computer, if you don't know how to, you're not computer savvy or tech savvy, as they used to call it, become a challenge. But I guess we're doing fine so far. We're not doing that bad. Okay. Now we can share this and that's one here. Okay. And the last shared will be here. Okay, so you see between this and that. In that case, that means we're going to find the two areas that represent both of them and then add the areas. Okay. Now, find the area that represent this negative 2.46, then on this one, then add them. That will give us the area. So for 2.46, negative 2.46. Now we go to the table. Remember, the negative sign is just to tell you that it's on the left side. So when you go to the table, you're not looking for negative 2.46. You're looking for 2.46. Negative is just to help you to draw the chart, the appropriate chart. So let's go there and then put it in. We have 2.46, negative 2.46. We have 2.4 here. You go under 6. So that's 2.46 right there. We have 2.4 under 0.4931. 0.4931. Then the other one will be the other z value would be 1.74. 1.74. Then so we're gonna look at it here. 1.7 under 4. 1.7 is right here. There you go, under 4. See, under 4. This is the 4 right there. And this is 1.7. 0.4591. 0.4591. Okay. So I've got it for both of them. I'm going to put them now. 4591. Okay. 1 minute. Yep. Anyway, we have 0 point. Make sure you're seeing this. Okay, I'm gonna make sure. So 0.4593 that is for negative 2.46. Then plus, because I'm going to add these two to get these two areas. For 1.74, we have 0.4591, 4591. Yeah, add them together, which I will show you from Desmos. So you have clear this 0.4931 plus 0.4591. 95.2, 0.9522. 0.95. Okay. So I'm going to write it down. 0.9522. Okay. 0.9522. Or if you like, you can call it 95.22%. Questions?
No.
Okay, so on Wednesday we'll be looking at how to do the opposite of this, how to find a specific z value with area, given a given area, given a specific z value for a given area. That means the opposite of this. Now I encourage you to have practice, as much as you can. You get stronger as you practice how to find these areas, or what they call probabilities in places and something, depending on how the question is asked. So like I said, on Wednesday, we start from here. Before we go, let me take down your attendance. Then you can, if I got Aaron is here. I got Ania is here. Bennett. Chambers. And then Taylor. So, okay. Now, if you don't have any question from me, feel free to leave, and I will see you on Wednesday. You all have a good day.
Okay, have a good one.
Have a good one.
Bye-bye. Mr. Taylor. Mr. Taylor, you have a question for me? Okay. I think he's gone.